Okay, so let's talk about the last little part, that being the two hemispheres of the brain. So, like we said before, the cerebral cortex, this top area, is split up into, well, sort of split up into two halves, two hemispheres, right? And this is all going to be connected by what's called the corpus callosum. Corpus callosum allows for communication between the two hemispheres, okay? And there is actually a fair amount of what we call lateralization of functions, meaning that certain functions are going to be almost exclusively in the left part of your brain, and certain functions are going to be mostly or entirely in the right side of your brain. I try to avoid saying entirely because although the left side is more to do with language and speech, there is some evidence that the right side you can do a very small amount of word comprehension. But for simplicity, yeah, the left side is going to be about language and speech, and the right side is going to be spatial and perceptual things like directions, and obviously, like you said, understanding kind of spatial level, right? So, furthermore, the left side actually has two special areas involved in speech and two different aspects of speech. So first of all, you have Broca's area, and this is going to be all about speech production. Okay? Broca's area is speech production. Wernicke's area is about speech and language comprehension. Okay? So what's really interesting is that when you look at people with damage to one of these areas, you get what's called the dissociation, and you get basically impairments in one function but not another. So when people have trouble, or say they have damage to Wernicke's area, they tend to have trouble comprehending speech but not so much producing it. Okay. In contrast to someone who has damage to Broca's area, they tend to have issues with speech production but not really speech comprehension. Okay. And also keep in mind that, like we said before, the left side is going to be corresponding to the left side of your brain is going to be corresponding to the right side of your body, including the visual field. Okay, so when you're looking at something using, say, you cover your right eye, and you're seeing something using your left eye, this is going to be processed in the right side of your brain. Okay. If you're seeing something with your right eye, this is going to be processed in the left side of your brain, kind of like this visualization here. Okay. So don't forget that. What's really interesting is that when you look at people with something, that with a severed corpus callosum, you could find all kinds of interesting things. So some people who have epilepsy will get their corpus callosum severed. Okay, so the corpus callosum that allows for communication between the left and right side. I'm not sure if they still do this today, but one way to treat that was to sever the corpus callosum. Okay, so to stop communication between the left and right side of your brain. Okay. Like I said, this is going to result in a lot of interesting findings because this means that the left side and the right side of your brain can no longer communicate. They can no longer talk to each other. So you get kind of different effects on speech and language, speech production and language understanding versus understanding of kind of shapes and visual, or not just visual, but spatial oriented things processing. Okay. So for example, if you deal with someone who has a severed corpus callosum, you give them this task. You say, look at the dot. What happens is that, okay, so the right side of their brain is going to be receiving everything to the left of the dot, and the left side of their brain is going to be perceiving everything to the right side of the dot. Okay? But remember that with normal people who don't have a severed corpus callosum, those two areas can communicate, so they can kind of put together the word heart, right? When you have a severed corpus callosum, you're more or less seeing those two things independently. So for example, if you ask people, say you only show them the right side, you only show them, or sorry, you show them both sides, but how you get them to indicate what's going on actually changes. That's your independent variable. So for example, if you show them art and it's split across the screen like that, keep in mind that he is going to be going to the right side of their brain and art is going to be going to the left side of their brain. Okay. When you ask them, what word did you see? So you're drawing on the left side of their brain, which is of course going to be about language and speech. They say, I saw art. Okay. However, when you tell them, okay, point to, you give them this card that you see here, which did you see, he or art? Point to what you saw. They actually point to he. Now the reason for this, actually let me just say that again so we're clear. This is a little confusing. Might be a little confusing. So when you tell them, respond verbally, what did you see? They say art. When you say point to what you saw, they point to he. Okay? The reason for this is that, again, there's no crosstalk, but pointing visually or spatially versus saying it are going to tap different areas of the brain, right? So because the right hemisphere is only going to have he in it and the left side is only going to have art in it, what that's going to do is, depending on how you ask them to respond, they can only respond with one or the other because there's no communication, right? So when you ask them verbally, what did you see? Verbally, remember, is going to be the left side of their brain. So they only have art in the left side of their brain. So they're going to say, I saw art, right? When you ask them to point, this is going to require something spatial, meaning it's the right side of their brain. So in that case, they're going to basically, because they have to point and tap the right side of their brain, they're going to rely on what's on the right side of their brain, that being he. Remember, he is on the left, meaning it transfers over to the right. Pretty wild. Okay, so quick recap. If a split brain patient saw a dog in their left visual field and a cat in their right visual field, what would they say they saw if they were asked to respond verbally? Dog, cat, both, or neither. Give me a minute to think about that. Okay. So, actually, sorry, I'll be a little longer. Okay, so the answer is going to be cat. Let's walk through this. So remember, split brain patient, corpus callosum is severed, the left and right side can't communicate. So they're not going to say both, right? They're also not going to say neither because the two can more or less function independently still, as we've kind of seen so far. So is it going to be dog or cat? Well, if you're going to ask them, okay, respond verbally, which this is obviously going to be speech, this is going to be language, it's not going to be spatial, right? So if they're using language abilities, remember this occurs in the left side of their brain. Left is language and speech, Broca's area and Wernicke's area, right? So remember, everything crisscrosses, right? So if they're using the left side of their brain, they're going to be processing what's in the right side of their visual field, right? So the cat is going to be on the right, so therefore they're going to pick the cat. They're going to say cat, right? In contrast, if you asked them, if you showed them a picture of a dog and a cat and you said, point to which you saw, you'd get the opposite result, right? You'd get dog. Because now, asking the point says, okay, use the right side of your brain. which is going to be processing the left, what's in your left visual field, and that's thought, right? So, your summaries from this lecture. The older brain structures are responsible for basic functions, things like breathing, heart rate, the most basic things you don't really have to think about. Limbic system is the middle ground between older brain structures with the cerebral cortex and is responsible for basic drives as well as emotions, like we talked about with the amygdala. The cerebral cortex contains our higher order structures, and so more complex things, perception, thinking, speaking, planning, inhibition, that sort of stuff. And this, remember, the cerebral cortex is divided into two hemispheres. Each has a specialty, the left being speech, the right being kind of spatial oriented stuff. Okay. Until next time.